Welcome to the Thunderbolts.info podcast for February 12th, 2016. If you're one of the many people around the world who's begun exploring the electric universe theory, then you've probably become aware of some very different ideas about how the universe actually works. This is a universe where nothing really lives in isolation from anything else. There is a conductive medium called plasma that pervades the physical universe. And electric currents flowing through plasma connect and influence separate bodies over vast cosmic distances. And in our own solar system, we see this principle demonstrated in the electromagnetic relationship between the Earth and the Sun. And scientists have actually known for many decades that the Sun is the cause of auroras on Earth. This was a confirmation of the hypothesis of the experimentalist Christian Berkeley. And in recent years, the evidence for the Earth-Sun electrical connection has grown more and more powerful. So the question is, if the Earth and the Sun are electromagnetically connected, and if the Sun's influence on the Earth is not merely limited to radiation and thermal heating and kinetic collisions of particles, and maybe if the Earth itself is a charged body that can be thought of as a kind of capacitor, then it seems inevitable that our basic understanding of the Earth's climate and weather needs to be dramatically reassessed. Do we really understand what it is that creates and drives weather phenomena? Now, under Thunderbolt's YouTube channel, we've occasionally addressed the issue of global warming, or so-called climate change. And in fact, we've even explored the recent discoveries of mysterious climate change on other planets as well as our own. Well, today we're going to be exploring this question from a very unique angle. Our guest is a gentleman by the name of Richard Moore, and Richard was a featured speaker at the Thunderbolts Conference EU 2015 in June of last year. I was recently able to watch the video of Richard's talk, which was called The Pulsating Universe and Planet Earth, and I really felt that it was one of the memorable highlights of the conference. Richard has explored the electrical theory of stars and the electrical environment of our own Milky Way galaxy, and he's applying those principles to a thesis that could provide an explanation for natural climate change here on Earth. And Richard's thesis is an example of how there really is not one set or dogmatic kind of electric universe hypothesis. There are different people coming into the community, and they have their own unique insights and unique takes on all things electrical. And so, Richard, whenever I'm interviewing someone for the first time who's coming into the electric universe community, I'm always interested in asking them how they first became introduced to the electric universe hypothesis. And I'm wondering, this whole question of climate change, is that an issue that you were exploring first? Or did you find the electric universe and see its applicability and relevance to the whole climate change debate?
Well, actually, I was interested in climate long before I heard of the electric universe model. Like everyone else, I was aware, of course, of all the publicity and concern and activism around what they originally called global warming and now they call climate change. But then every once in a while I would read an article that had a lot of scientific clout behind it and presented what looked like strong evidence that the global warming hypothesis wasn't valid. And so I didn't know what to believe. And I'm not somebody who likes to just let things go like that. So I decided that what I was going to do is actually download look for climate data on the official climate data on the web and download it and look at it myself. So it didn't take very long to find the NOAA, what is it, National Oceanographic Aeronautics or whatever administration. And I found the ice core data for Greenland and for Vostok, which is in Antarctica. So I had the Arctic ice core record and the Antarctic ice core record, which seems to be the most accurate and reliable long-term record of climate, record of Earth temperatures. And I started looking at that. And it became apparent very quickly that there isn't really anything unusual going on with respect to climate. So just to give an overall picture of what climate variation has been, if you look at the record for the last 400,000 years, which is what the Vostok record shows, you see that the Earth is almost always in what we call an ice age, and it's only every 100,000 years approximately that there's a sudden spike in temperature, a very sudden spike, and a very short-lived spike. So we have about something like 10,000 years of what we have now, an interglacial period, and then the temperature falls rapidly again down to the next ice age. So it's good just to have an overall pattern of what happens on the Earth. Then it's interesting the kind of pattern. There's those spikes every 100,000 years, like I said. But if you look at the graph, there's another set of smaller spikes that occur about every 10,000 years. So basically, what the climate record is spikes on different scales. And the spikes occur with an approximately regular frequency. So it's a fractal pattern. All I knew is that these were natural things. This is all looking before there was any industrial age. And I didn't have any idea what might be causing it, but I said, well, this is the natural pattern, and we better know about the natural pattern if we want to start talking about something being unnatural. So then I looked at just the tail end, just the last 10,000 years or so of the graph. And lo and behold, you get another series of spikes, only they're about every 1,000 years. And then within that, there's even smaller spikes. So in other words, it spikes all the way down, different frequencies. Now, the one for the last 10,000 years, what you can see, and now I'm looking at the Greenland record, the northern hemisphere. What you see is spikes that go up at the beginning and flatten out, and then they go down at the end. So basically, there's a spike at about minus 1,000, a spike at the year 0, a spike at the year 1,000, and then it goes down to about 1800, goes down to a minimum. And lo and behold, what they call global warming is one more spike occurring just about when you would expect it to occur, the year 2000. And then so I found that very interesting. I said, well, yeah, there's been 200 years of global warming, and it follows the natural pattern. And according to that natural pattern, it should turn around and start down around the year 2000. So I did some research looking for different articles, and lo and behold, there were about 5 different kinds of ways of measuring, all of which showed that the global warming rise stopped about the year 2000. So I found that very interesting, but I didn't have any reason to think I had any theory about why we had this spiky pattern and why it was now going down. And then I forget how I heard about it, but I heard about the electric universe, and I bought the book, The Electric Sky, and read that. And it was just, it was just so obviously that it had to be true, because what you see in the cosmos are, these beautiful images, like from the Hubble telescope and everything. They all look like the kind of plasma discharges that you can create in the laboratory. And we know that the universe is 99% plasma. So if what we have is the plasma universe and what we see are what look like plasma discharges, then it makes a whole lot of sense to assume they are plasma discharges.
Right. That's way too common sense an approach, though, Richard.
So then I put the two things together. What I noticed about all these spikes being our record, and the fact that the universe is filled with electric currents. And we know, I'm looking at graphs as I talk, and I think you're going to be able to put some of those up with our podcast. One of the graphs shows the current. There's a current that comes into the sun at both poles. That's what powers the sun. That's what makes it shine. But most of the current, it goes around the chromosphere, around the corona, and then goes out over the equator. That's what's called the equatorial current sheet. So that current is coming out across over the plane of the equator of the sun, and so it goes to all the planets. So there's a current that goes from the sun to the earth. And again, just as with the sun, the current comes in at the north and south poles, and it goes through the ionosphere mostly. Some of it comes down as lightning and weather events, just like some of the current goes into the sun and causes it to shine. Some also comes into the earth, but most of it goes around through the ionosphere and then goes out over the equatorial plane of the earth and rejoins the current that's flowing away from the sun. So that current that comes into the earth, that's what's visible as the aurora, the northern and southern lights. Now, nobody's going to get sunburned from standing under the aurora, so it's not obvious how the fact that an electrical current comes in to the earth, how that might cause heating. It still isn't obvious how that happens. But the fact is that what else besides an electric current can cause spikes of energy on all different scales? Like the standard theory for the ice ages is that the earth gets closer and further from the sun, But if it were an orbital variation of any kind, it would be exactly regular. It wouldn't be approximately regular. An electric current can carry any charge. I mean, can carry any amount of current. Like that's why you have spike protectors on your computer power supply, because there could suddenly be a spike coming over the current. So, and if like one thing I did just kind of for fun is I recorded some music and then looked at the graph, and what you see is something that looks almost exactly like the climate record. It's all spikes at all different scales. So the point is that an electric current is capable of carrying a fractal pattern that goes over a very, very wide range of scales. And and they're usually cyclical. There's usually some kind of discharge circuits tend to have cyclical patterns in them.
That's an interesting point to raise because our most viewed space news to date was on a so-called impossible neutron star. Scientists they observed what appeared to be a pulsar with a brightness of, I think it was 10 million suns, and so that was a big problem. But I hear from apologists for the mainstream viewpoint, and they say, well, it's the periodicity of a pulsar. It has to be created by this kind of mechanical spinning lighthouse effect. It couldn't be something electrical because then you wouldn't get this kind of regular pulsing signal. What are your thoughts on that?
Well, you can create discharges in the laboratory that pulse. I mean, electrical electrical circuits do pulse. That's how radio works. You have a capacitor and a resistor and a power supply, and depending on how they're set, you can decide what frequency you're getting. That's how you tune a radio. So that's standard behavior for circuits. So in other words, I had this hypothesis that the Earth's temperature record and the fact that we're connected to an electrical circuit could be it could be an electrical thing that causes climate change. But I didn't have any empirical verification of that at first. Then, when I went to the Electrical Universe conference in June, I gave my talk. There was another talk, but he showed that the sunspot cycle, which is the sunspot, the number of sunspots basically is measuring the electrical input to the sun. The more sunspots, the more electrical energy coming into the sun, which means the more electrical energy that reaches the Earth, because it's going to be proportional. Double the energy into the sun, then you're going to double the energy into the Earth. Well, there was a minimum of temperature around somewhere in the 1650, 1700, around in there. If you look at the temperature record for Greenland, and it turns out there was a very clear minimum of sunspots at the exact same time. So and then since then, the sunspots have been increasing and temperature has been increasing. So there is a very definite, strong, not a slight, not one of these things that points 1%, but there's a very strong linear correlation between electrical input and temperature. Sort of is a strong verification of the hypothesis that it is electrical input to the Earth which is causing climate variation.
Okay. Now, what might you say to a critic who rejects the very notion of an electrically powered sun or even an electromagnetic connection between the Earth and the sun? When, for instance, the auroras here on Earth, science now recognizes that the sun is the cause of the auroras, but they're still thinking in terms of collisions. So, what do you believe is some of the best evidence that the sun actually is an electrical phenomenon?
Well, I mean, that's really a problem for the whole electric universe community is how do we how do we get people to look at the data? I mean, if you the Thunderbolts.info website, I think, does a very, very good job. It's not that we don't have the arguments. It's not that we don't present them well. It's not that we don't have data. It's that mainstream cosmologists and mainstream astronomers, they're just not tempted to look at it. If someone told them, oh, there's an electric model of the universe, they'd say, geez, well, there's also sites that talk about UFOs, right? You know, I mean, they just dismiss the idea. If we could get them to actually look at what is on the Thunderbolts info website, I think that works. You know, I don't think there's any failure in our presentation abilities.
Well, on the climate change debate, in most of the so-called debates that I've seen, we don't see an alternative view of the sun or the Earth-Sun connection really being presented. A lot of the discussions are political, and there's also debate over the question of CO2 and a question of the cause and effect relationship between CO2 and warming. So, what are your thoughts on that? Is there a correlation between CO2 and warming, or is it the other way around, or do you think the whole issue is horribly overinflated?
Well, the thing is that if you look at the articles they are publishing, they always say things like hottest year on record since records have been kept. Well, the thing is they didn't start keeping records until into the 1800s. And there has been 200 years of warming since 1800. There's no doubt about that. It's just that matches 200 years of warming we've had in the year minus 1000, in the year zero, and in the year 1000. And so now we're having a peak in 2000. So there was an accidental in correlation between the beginning of the Industrial Revolution and a natural temperature rise that was going to occur anyway. Now, why the so-called climate scientists aren't looking at the long-term record? That's I think a political question. I think there's political reasons for that, which is really a different subject. But the fact is that if you look at the long-term record, you can see that this correlation between carbon dioxide of the Industrial Revolution and 200 years of warming has been a complete coincidence. And it turns out that, let's see, we have one graph here from John Christie of the Earth System Science Center. And what it shows is it shows a red line, which is what the CO2 models say is going to happen with temperature. And then they have a green and a blue line, which would show the actual measured temperature from satellites and other sources. Up until almost 1995 or so, they were tracking each other. The CO2 models were tracking temperature. But beginning just before the year 2000, the CO2 models are now going way up into the stratosphere, and the actual real temperatures are flattening out and beginning to decline. So that really tells the story. It's been an accidental correlation, and now the correlation is breaking down because nature's. And the other thing is that the rate of increase of heating was not any higher than normal. In other words, there could have been both CO2 warming and natural warming. That would have been possible. But then the spike would have gone up at a steeper rate. But it's not. It's going up at exactly the same rate that it went up the previous three spikes. So there's no evidence whatsoever of any influence from CO2. If you actually study I mean, I've seen studies of greenhouse gas effect. Okay. And so, I mean, you can study CO2 as a greenhouse gas in a test tube or in a beaker, or, in a laboratory. And what you find is that it's a logarithmic thing where if you start off with no CO2 and put some in, then you get a very rapid rise in temperature. But as you begin to get a certain level of CO2, then the effect of it drops off to almost nothing. So by the time you get to about 265 parts per million, you're not getting any effect at all of adding more CO2. So, in other words, we already had experienced the maximum that CO2 can contribute to warming before the industrial age even came along.